Professor Deb here with Technical Mathematics. In this video we're going to be discussing the basics of sine and cosine graphs. At any time, pause, stop, or replay the video. Let's get started. Here's a circle. When we talk about sine and cosine graphs, these are explained in the term radians. So first let's determine the circle in degrees that we're familiar with. We know this is 0 degrees, and we know this is 90 degrees, right? And we know this is 180 degrees. This one's kind of the tricky one, 270 degrees. And when we come all the way around the circle, this point also equals 360 degrees. Now let's put those terms in radians. They're the same distance on the circle, they're just put in different terms. So 90 degrees equals pi over 2. 180 degrees is the same thing in radians as pi. 270 degrees is 3 pi over 2. And when we get all the way to 360 degrees, that's equal to 2 pi. And this is a term we're going to be working with a lot, 2 pi. Because 2 pi is one distance all the way around the circle. And a lot of times we want to find out what our sine or cosine equation says, how frequently it goes up and down within 2 pi. And we'll talk about those terms. We'll talk about the period, we'll talk about the phase, and frequency, and we'll get into all that. Let's get started. Let's get going. Okay, here I want to talk to you about sine and cosine waves and show you exactly what they look like. First we'll need an equation. So let's see. We'll start off with y equals, and we'll put, let's see, 3 sine x. Now a couple of terms first. This number in front of the word sine or eventually cosine refers to the amplitude. This will be the highest point or lowest point of our curve. So let's put this down here on the curve where it belongs. We'll have a positive 3 and we'll also have a negative 3. So the curve will go between 3 and negative 3. Now right here, you can put a 1 in here since there's no other number in that. And that refers to the period. Now in this case, since it's 1, our period is 2 pi. So how we figure out the period is, we always take 2 pi, that's a full circle, remember, and we divide it by the number in front of x. So 2 pi divided by 1 equals 2 pi. Okay, let's put 2 pi in here, that's where it's going to end. Okay, now our wave, or our curve, is a sine curve. The sine curve, let's put another little bit of information. The sine curve starts at 0, 0. And we'll see how different that is with cosine curves. So here's 0, 0. This is about halfway. So since it's a positive 3, we're going to go up to maximum amplitude, come down to minimum amplitude, and end at 2 pi. All right? That's a sine curve. Now let's take a look at how that differs to a cosine curve. We'll put an equation up here. Y equals, let's use 5 this time. 5 cosine, and we'll still use x. So there's no number in front of the x, so we'll just put a 1. Okay. Our amplitude actually equals, as we saw, it was 5 and negative 5. Therefore, we say that it's the absolute value of 5, which equals 5 and negative 5. So we'll put 5 here at our maximum amplitude and negative 5 here at our minimum amplitude. Now again, we've got 1, so our period equals 2 pi divided by 1 equals 2 pi. So it's going to make one wave in the distance all the way around the circle. Let's put 2 pi in here. Let me try something a little fancy. See if this works. It's a cosine curve. Now a cosine curve says that we start at minimum or maximum amplitude. Now in this case it's a positive 5, so we want to start at positive 5, and halfway again is here. So let's see if we can draw this line or this curve. Here we are. One wave didn't quite hit that right. That should have crossed right there. But it makes one wave within 2 pi. All right? Ready for more? Here's an equation. We have 3 sine x. Okay? Our amplitude equals the absolute value of 3, which equals 3. Okay, let's put that on here. 3 and negative 3. And again, there is no number in front of the x, so we'll just put a 1 there. And our period again is 2 pi over 1, which equals 2 pi. Okay, so we'll put 2 pi over here. We know that's where it ends. But we want to go a little bit further. We want to find out what this midpoint is, what this quarter point is, and what this 3/4 point is. So let's do that. If we take 2 pi and we multiply that by 1/4, remember we want 1/4 of the distance, 1/4 of the total wave. So we can simplify that, and we should end up with pi over 2. Okay, that's our point here. Pi over 2. Now let's find out our midpoint, okay? 2 pi, and this time we'll multiply it by 1/2, because it's 1/2 the distance. And then if we simplify that, it drops out to pi. So we can label this as pi. Well, if you've caught on now, you know that this point is 3/4, so we're going to multiply 2 pi times 3/4. I have to make sure I simplify this. We'll have 3 pi over 2. Those numbers sound familiar from our original circle that we talked about? They should. Okay, we'll put 3 pi over 2. Okay, now it's a sine wave. A sine wave says that it starts at 0, 0 point, and it's going to end at 2 pi. So what we need to do, start here, going up, down, and ending at 2 pi. There we go. Again, the curve's a little shaky, sorry about that, but we can get the idea. This, we've changed the amplitude, and now we can describe when at maximum value here, it's also at pi over 2. And at minimum amplitude, it's at 3 pi over 2. All right, let's keep going. Okay, we got a little bit more complicated one here. We are talking, here's our amplitude, so let's put that down. Equals the absolute value of 5, which equals 5. Okay, now this time we've got a 6 here. Remember, we always want to find out how many waves in a full circle, or 2 pi. So we always use 2 pi. And this time we're going to divide it by that 6. So if we simplify, we should have pi over 3. So now our ending point is no longer going to be 2 pi, but it's going to be pi over 3. And we said our amplitude was 5 and -5, so let's go ahead and put that in there. Now, we are going to make one wave from 0, 0 to pi over 3. How about we find those in between values again? So if we take pi over 3 and multiply it by 1/4, we get pi over 12. Now I'm sure you can guess pi over 3 times 1/2 is pi over 6. And how about that last one? Pi over 3 times 3/4 of the length, or 3/4 of the wave, would be pi over 4. So let's put that in. we're going to have pi over 12, pi over 6, and pi over 4. Now let's see if we can get our wave. It's a sine wave again, and it's going to go from the 0, 0 point, because it's sine, and it's going to end at pi over 3. So we're going to start here. We're going to go up to maximum amplitude, come down, cross over, down to minimum amplitude, and end at our period pi over 3. Right, so now we've introduced a value. If we took this all the way out to 2 pi, it actually would have several waves. So that's the difference. Let's keep going. Okay, here's a new one. Now notice, we have a couple things here going on. First of all, we know that we need the number in front of the x. So let's take a minute and let's rewrite this so that you can see what this really stands for. 5 cosine 1/3 x. See, it looks very different that way. Okay, so our amplitude, this is where the absolute value comes in, -5 equals 5. So we have 5 and -5 here. Okay, now our period. Our period is 2 pi divided by a fraction, 1/3. Hopefully you remember that when we have a fraction in the lower part of a fraction, we invert it. So we'll take 2 pi and we'll invert it to 3/1. That means what we get is 6 pi. Wow, this is going to be a long, stretched out curve. We have 6 pi here. Okay, in the middle, you know we have half of that, 3 pi. Let's just write out a quarter. So we simplify, and that'll be 3 pi over 2. And let's do 3/4 while we're at it. 6 pi times 3/4 equals, let's see, 9. No. Yeah, that's right. Pi over 2. Okay, we'll put that in. 9 pi over 2. And 3 pi over 2. All right, it's time to draw our curve. This time we have a -5, and it's a cosine. Cosine says that we start at maximum or minimum amplitude. Now in this case, we're going to start at the minimum amplitude because it's a negative number. So we're going to be at minimum amplitude when we start, maximum amplitude in the middle, and minimum amplitude when we end. So let's see if we can get that curve in there. There we go. A little divergent there. There we go. And that is a cosine curve. So you can see if we were to put 2 pi in here, this would just go up and down and up and down and up and down. It's a different kind of curve. We're only drawing one wave of it. Alright, think you got the idea? Ready to try one on your own? Here's one to try on your own. Stop the video and try this, and then look at the answers in the information tab. I'm going to help you out just a little bit here. See this -2? Well, it actually comes in front here. So it's actually y equals -1/2 sine 3x. Okay? So you should be able to take it from there. Okay, hopefully you stopped the video and got the last question correct. Here's another question for you to try. This has an amplitude of 7, and it has a number before the x. So you're going to have to put 2 pi over that number. And remember that it's a cosine, so it's going to start at maximum amplitude or minimum amplitude. Again, stop the video, try this question, and check your answers in the information. That's all for this lesson.